Hello, my dear friends, how are you all? I hope you all are good and fantastic. So, my dear friends, you are very welcome in our lecture number 1 of probability. Okay, so my dear friends, I hope you will enjoy this lecture because this lecture is going to be very amazing. Okay, so you have to be listen very carefully, my dear friends. Okay, so without wasting the time, let's start. Yes. So my dear friends, today first of all we are going to discuss about the introduction of probability. Okay. So basically we have to know what is probability. Okay. So my dear friends, probability is the branch of mathematics that measures the uncertainty of the occurrence of an event using numbers is called probability. I hope, my dear friend, you understand these things. Okay, so the chance that an event will or will not occur is expressed on a scale range from 0 to 1. Okay, means the event may happen or not. Okay, this this chance we can express on a scale range from 0 to 1. Okay, it can also be represented as a percentage where 0% means an impossible event. Means this is an impossible event. If it is 100%, so we can say that a certain event. We can say that this is possible or sure event. This is what? Possible and sure event. I hope, my dear friends, you understand these things. Okay, so now let's move on. Yes. So now let's understand what is events and what is outcomes. What is event and what is outcomes. So my dear friends, an outcome is a result of random experiment. An outcome is a result of random experiment. For example, when we roll a dice, getting 6 is an outcome. Getting 6 is an outcomes. Okay, I hope you get this point. Now if you talk about the event, a probability event can be defined as a set of outcomes of an experiment. It is a set of outcomes. In other words, an event in probability is the subset of the respective sample space. Now what is sample space? Let us see. So my dear friends, the entire possible set of outcomes of a random experiment, the entire possible set of outcomes of a random experiment is a sample space or the individual space of that experiment. Okay, like the likelihood of occurrence of an event is known as probability, and the probability of occurrence of any event lies between 0 and 1. Let's suppose, for example, we are rolling a dice. Okay, so now what are these sample space? So there is a set like 1, 2, 3, 4, 5 and 6. This is what? This is our sample space. This is the sample space. Okay, so entire possible set of outcomes. So this is the entire possible set of outcomes. Okay, if we roll a dice, then 1 may also come, 2 may become 3, 4, 5 and 6. So maximum till 6. Okay, so my dear friends, I hope you understand these things. So this is the entire set. Now if we toss a coin, okay, in tossing a coin, then in this case what are the sample space? So the sample space SS, so the sample space is head and tail. It may be head or it may be tail. So this is what? This is the sample space. I hope, my dear friend, you understand these things. So that's why we can say that event is in probability is the subset of the sample space, respective sample space. So my dear friends, I hope you understand these things. Okay, so now let's move on. So now my dear friends, our next topic is probability of occurrence of an event. What is probability of occurrence of an event? So my dear friends, this is the number of favorable outcomes to the total number of outcomes. The number of favorable outcomes to the total number of outcomes is defined as the probability of occurrence of an event. Okay, I hope you get this point. So the probability of event like this. Probability of event, we can represent it is like as, which is equal to number of favorable outcomes divided by total number of outcomes. So this is the probability of occurrence of an event. Okay, now my dear friends, in this, what is favorable outcomes? So my dear friends, let's suppose we are rolling a dice, okay, and we have sample spaces 1, 2, 3, 4, 5, 6. Okay, so now my dear friends, if we say that what is the probability of even number? So this is the total number of outcomes. Means this is sample space. Now if you talk about favorable outcomes, FO, so we are talking about the even number. So what are these? So the even numbers are this, and this. So here is 2, 4 and 6. So this is what? This is favorable outcomes. So my dear friends, you understand this? What is favorable outcomes? What is total number of outcomes? I hope my dear friends, you understand these things. Okay, so my dear friends, let's move on. Now here is impossible and sure events. What is impossible and what is sure events? Okay, so now we are talking about impossible event. So my dear friends, if the probability of occurrence of an event is 0, if the probability means P of E is 0, okay, such an event is called the impossible event. Such event is called impossible event. I hope my dear friend you understand these things. So this is the case of impossible event. Okay, so now let's suppose we are talking about, for example, like this. Now find the probability of 7 when we roll a dice. Okay, so what is the total outcome? So the sample space is SS 1, 2, 3, 4, 5 and 6. Okay, now we have to find the probability of 7. Okay, so favorable outcomes is what? Favorable outcomes is 0 because there is no 7 in the dice. Okay, so in this case probability of event which is 0, so this is the impossible event. This is the example of impossible event. I hope my dear friend you understand these things. Now if you talk about sure event, so what is sure event? Okay, so now if the probability of occurrence of an event is 1, then it is called the sure event. Means if P of E, probability of occurrence of an event is 1, then this is the case of sure event. Sure event. Okay, I hope my dear friends you understand these things. Okay, so if we take the example like this, let's suppose we have a sample space of dice. What is 1, 2, 3, 4, 5 and 6. This is the sample space. I hope my dear friends you understand these things. Okay, so my dear friends, if we find that what is the probability of a number less than 7. Okay, so what is the probability of a number like P of E? What is the probability of a number which is less than 7? So my dear friends, less than 7 means it is, yes, it is 6. It may be 6, 5, 4, 3, 2, 1. But this is what? This is the sure event. This is the sure event. Okay. So all these numbers are what? All these numbers are less than 7. All these numbers are less than 7. So this is the sure event. In that case, if 3 come, then it is also the probability is 1. If 5 come, then the probability is 1. Okay, my dear friend. So whole this sample space is the sure event in that case. I hope my dear friends you understand these things. Yeah, so now let's move on. Yes, now what is simple event? So my dear friends, any event consisting of a single point of a sample space is known as simple event in probability. For example, let's suppose we have a sample space is like 56, 78, 96, 54 and 89. Okay, I hope you get this point. Now if we take E is equals to an event which is 78. Okay, then this E is what? The simple event. This E is a simple event. Okay, so this event, okay, consisting of a single point of the sample space Okay, so this is the simple events. So now my dear friends, independent events and dependent events. So what are these? Let's see that. So my dear friends, if the occurrence of any event is completely unaffected by the occurrence of any other event, such events are called independent events in probability. Such events are called independent events in the probability. Like for example, rolling a dice, rolling a dice and flipping a coin, flipping a coin. Okay, so these two events are what? They are independent events. They are independent event. They are separate. Okay, so because in this rolling a dice, outcomes is different. Outcomes is different from the flipping a coin. Okay, so both have the different outcomes. So we can say that these two events are what? These two events are independent events. Okay, now if you see the second example, here is riding a bike and watching a movie. Okay, so these two events are again independent events. Okay, so I hope you understand these things. What is independent events? Got it? Yes, so now let's talk about the dependent event. So when two or more events are dependent on one another, then we can say that they are the dependent event. Okay, so now if we see the examples of dependent event, so here is, see the example, so here is driving a car, okay, and getting in a traffic accident, in a traffic accident. Okay, so these two events, driving a car, okay, and getting in a traffic accident, so these two events are what? They are dependent event. They are what? Yes, they are dependent event. Okay, so I hope you understand these things. So now let's move on. So now, my dear friends, range of probability of an event. Range of probability of an event. The range of probability of an event lies between 0 and 1. This 0 and 1 are included, okay? For example, that is, probability of event is always less than and equals to 1, but always greater than and equals to 0. This is the range of, yes, this is the range of probability of an event, okay? So now, elementary event. What is elementary event? So now, my dear friends, an event having only one outcomes of the experiment, having only one outcome of the experiment is called an elementary event, is called an elementary event. For example, my dear friends, first of all, take the experiment of tossing a coin in number of times. Tossing a coin and number of times. Okay. So my dear friends, we are tossing a coin. We are tossing a coin and number of times. And number of times. Okay. So one trial of this experiment has possible outcomes what? So the sample space is what? Head and tail. These are the sample space. Okay. So for an individual toss, it has only one outcome. Okay, it has only one outcome, that is head or tail. So this is the elementary event. This is what? This is the elementary event. You can toss a coin n number of times, no matter. Okay, but the outcomes is just only one, head or tail. I hope you understand this. What is elementary event? Okay, so an event having only one outcomes of the experiment is called the elementary event. Is called the elementary event. Okay, so now, yes, now sum of the probabilities. So my dear friend, the sum of the probabilities of all the elementary events, of all the elementary events of an experiment is 1. Let's suppose, for example, we are tossing a coin experiment, okay, and we have sample space, head and tail. Okay, so now if we say that, what is the probability of head? So this is what favorable outcomes is, in this case favorable outcomes is head, which is 1, okay, and total outcomes is 2, so we can say this is 1 upon 2. Okay, now if we say that, what is the probability of tail? Okay, so this is what? This is same again, 1 upon 2. Okay, now if we say that, what is the sum of these probabilities? So P of head plus P of tail is equals to half plus half, which is equals to 1. Okay, so we can say that probability of sum of all the elementary events, all the elementary events, this is always 1. I hope you understand these things, my dear friends. Okay, so now let's move on. Yes, complementary events. So now, my dear friends, what is complementary events? Okay, so my dear friends, Two events are said to be complementary when one event occurs if and only if the other does not. One event occurs if and only if the other does not. For example, let's suppose we are tossing a coin, okay, and let P of E is the event, the probability of getting tail when a coin is tossed. Okay, it is the probability of getting tail. Okay, my dear friends. So now, what is this? So this is 1 upon 2. Okay, because we have sample spaces what? Head and tail. So now, my dear friends, if we say that, now what is the probability of not getting tail? Means probability of not getting tail. Means we can write it as P of E bar. This is the sign of complementary. Okay, P of E bar. Okay, it means that we are asking the probability of not getting tail. So P of E is what? Probability of getting tail, and P of not E is what? Probability of not getting tail. This is what? This is, listen, if tail is not come, then head is come. Okay, so in that case, we are asking indirectly what is the probability of head. What is the probability of head? So this is 1 by 2. This is what? This is 1 by 2. I hope you understand these things. So my dear friends, for any event, there exists another event, okay, which shows the remaining element of the sample space. Okay, so now here is probability of E plus probability of complementary event. This is the complementary event, okay, which is always equals to 1. Probability of getting or probability of not getting, means probability of event and probability of complementary event is always 1. I hope my dear friends you understand these things. So now let's move on. So now my dear friends, so the next topic is theoretical probability. So now what is theoretical probability? What is theoretical probability? So the theoretical probability states that it is the related to the theory behind probability. Okay, in theoretical probability, my dear friends, we utilize the knowledge of a situation to calculate the probability of an event. Okay, in this my dear friend, there is no experiment. There is no experimental event. There is no experiment. Okay, means we do not conduct any experiment. Instead, we just use the knowledge of the situation. We just use the knowledge of the situation. Okay. Okay. So now the formula. What is the formula? Okay. What type of formula we are using in this theoretical probability? So my dear friends. So the formula is the probability of occurrence of an event like P of E. P of E is equals to, okay, is equals to the number of favorable outcomes divided by total number of outcomes, which we learned earlier in this lecture. Okay, so what is number of favorable outcomes? Favorable outcomes divided by total number of outcomes. Total number of outcomes. I hope my dear friends you understand these things. What is theoretical probability formula? Okay, let's see the examples. Like, let's suppose we have a dice. We have a dice which having a sample space is 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. Now my dear friends, we have to find the probability. We have to find the probability of 4. Okay, we have to find the probability of 4. So now in this case, favorable outcomes is what? Favorable outcomes we have 4. Okay, so we can say that total outcome we have 6 and favorable outcomes we have 1. Okay, 1 times 4 can become come. Now if we find the probability of event, which is equals to, we know that favorable outcomes divided by total outcome, which is equals to what? Which is equals to 1 upon 6. Okay, which is equals to what? 1 upon 6. So my dear friend, this is the theoretical probability. This is what? This is theoretical probability. In this probability, in theoretical probability, we are not doing any of the experiment. We are not doing the experiment. Okay, we are just using our knowledge. We are just using the theory. We are just using the formula. With the help of this formula, we are finding the probability. Now my dear friend, let's come on. Yes, now experimental probability. What is experimental probability? So my dear friend, it is also called as empirical probability. Okay, so now it is calculated on the basis of performance of actual experiments or trials and their outcomes. In this, my dear friends, experiments are conducted in a serial manner. Okay, so these are called random experiment. Okay, as the result of these experiments are unpredictable. We cannot predict any of the experiment. I hope my dear friend you understand these things. Okay, so now in this case the mathematical formula is P of E, probability of occurrence of an event, is what? This is, there is the number of event, means how many times of event is occur. Okay, so the number of times event occurs. Okay, divided by total number of trials of the experiment, divided by total number of trials of the experiment. So now my dear friends, let's see the example related to the experimental probability. Okay, yes. Question number 1 is, you ask your 3 friends Sakshi, Shreya and Ravi to toss a fair coin 15 times. In this we are tossing a coin 15 times each in a row, and the outcomes of this experiment is like, here is, if coin tossed by the Sakshi, then the number of head out of 15, number of head is 16 times come, and number of tail is 9. Okay, if you talk about the Shreya, number of head is 7 out of 15 and number of head is 8 out of 15. And if you talk about Ravi, number of head is 8 and number of tail is 7. Okay my dear friend, so the question is, calculate the probability of occurrence of head and tail. Now we have to find the probability of head and tail individually. Okay, now my dear friends, experimental probability for the occurrence of head. We know that what is the probability of occurrence? So probability is number of times tails occurs. So the probability is, we are talking about head, so this is number of head occurs divided by total number of coins is tossed. Okay, so now in the case of Sakshi, in the case of Sakshi, what is the probability? Number of head is what? 6. So this is 6 divided by total number of experiment is 15. So this is 6 upon 15, which is equals to 0.4, which is equals to what? 0.4. Now in the case of tails, this will be 9 upon 15, which is equals to 0.6. Okay, my dear friend, I hope you get this point. Now in the case of Shreya, we get 7 upon 15, because number of head is what? 7, and total number of trial is what? 15. Okay, so this will be 0.47. I hope, my dear friend, you understand these things. Now in the case of tails, we get 8 upon 15, which is equals to 0.53. Okay, now if you talk about the Ravi, in the case of Ravi, the probability of head is what? 8 upon 15, which is equal to 0.53. Okay, and in the case of tail, this will be 7 upon 15, which is equals to 0.47. So this is what? This is the experimental probability example. Okay, my dear friends, I hope you understand these things. So now, my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay, so thank you very much for listening me, and take care and goodbye.